The overall goal of this experimental procedure is to quantify and improve the understanding of the ignition requirements and the resulting burning efficiency of crude oil spilled on water for oil spill response purposes.
This protocol can help answer key questions for the in-situ burning of crude oil spills, such as the strength and the exposure time needed for the ignition source. The main advantage of these laboratory experiments is that the flammability and the burning efficiency of crude oils can be studied simultaneously under conditions that represent operational scale crude oil fires.
Begin preparing oil samples for the experiments. Use this plastic container for the weathering process. It has holes drilled into its lid. There is also a hole in its side to accommodate a plastic tube connected to an O-ring with holes. Set up the container to bubble air through several liters of fresh crude oil. During the weathering process, monitor the oil's weight to know the weight percentage loss over time. Stop when the desired value is achieved, which can take several days. Emulsification of crude oil requires a rotary shaking table. First, vigorously shake 900 milliliters of the desired crude oil and water mixture for 1 to 2 minutes. Then place the bottle on the rotary shaking table to stir at room temperature. The crude oil flammability apparatus, or COFA, is under an exhaust hood. It is a metal water basin with an inlet and drain. For the test, prepare a glass cylinder. It should be 5 centimeters high and about 16 centimeters in diameter. Mount the cylinder on a stand and place the stand and cylinder in the center of the basin. Proceed by filling the basin with fresh water. Stop when the water is 1 centimeter below the edge of the glass cylinder. Mount a propeller on the basin wall to directly face the glass cylinder and adjust its height. Set its height and speed so the waves generated are barely observable in the water inside the cylinder. Turn off the propeller and prepare the oil. Pour the oil carefully on the water surface inside the glass cylinder. Next, slowly add water to the basin and stop when the surface of the oil slick is 1 to 2 millimeters below the edge of the cylinder. Start the propeller and prepare to time the burning. Use a butane hand torch to ignite the crude oil. Record the time from ignition until extinction. When the fire has extinguished, use hydrophobic absorption pads to collect the remaining oil. Shake any collected water off before weighing the pads to determine the burning efficiency. Have a different setup ready under a hood to study flammability. Use a cone heater equipped with shutters and a spark igniter. This heater also features a custom-made sample holder. This schematic highlights the features when the two are put together. The cone heater sits 23 millimeters above an oil slick which is in a metal holder. Valves regulate cooling water that flows below the oil. This schematic provides a sense of the elements beyond the heater and sample holder. There is a control unit for the cone temperature and the spark igniter. The complete water system is revealed, as is the presence of a gas analyzer that samples the exhaust gases. Start by heating the cone so there is a heat flux of 3 to 50 kilowatts per square meter at the oil surface. Also, cool the reservoir to a previously determined temperature. When all is ready, connect the water tubes to the sample holder and get water flowing through the system. Shake the sample holder to remove trapped air. When the cone and sample holder temperatures stabilize, stop the pump. Close the valves on both sides of the sample holder. Then disconnect the tubes. Take the sample holder to a load scale and tare the scale. Add oil at room temperature to the sample holder equivalent to a 10 mm slick thickness. When done, reconnect the sample holder, open the valves, and restart the water flow. After starting data acquisition, carefully place the sample holder under the cone. Prepare 2 stopwatches and move the spark igniter over the sample. Next, open the cone shutters and start the first stopwatch. When the oil ignites, stop the first stopwatch and start the second. Then move the igniter into its neutral position. Wait for the fire to extinguish to stop the second stopwatch. Close the shutters and stop the data acquisition. Next, stop the water flow in the sample holder, close the valves, and disconnect the tubes. Place the sample holder on a tared scale and register its weight with burn residue. Clean the holder with a volatile non-polar solvent. Weigh it again to determine the residue weight and thus the burning efficiency. Return to the COFA. Place a glass cylinder on a stand in the center of the apparatus. Next, put 2 water-cooled infrared heaters on adjustable footings into position on either side of the cylinder. Position them 1 to 5 centimeters from the cylinder's outer edge. Fill the crude oil flammability apparatus with water. The water level should be 1 centimeter below the edge of the glass cylinder. Place a propeller facing the cylinder at the previously determined height. Now prepare thermocouples for the cylinder. Mount 3 1 mm thick K-type thermocouples on a frame. Suspend this frame over the cylinder. Orient the frame so the thermocouples are along a radius 1 to 2 millimeters below the cylinder edge. Slowly add water to the basin and check that the water touches each thermocouple at the same time as a test of their placement. To continue, drain the water so its level is again 1 centimeter below the edge of the cylinder. Ensure a spark igniter can easily move between a neutral position and the cylinder's center. Start it in the neutral position. Pour crude oil equivalent to a 5 mm thick slick onto the water inside the glass cylinder. Add water until the oil just comes into contact with the thermocouples. Move the spark igniter into position above the oil. Start data acquisition and a stopwatch simultaneously. Turn on the exhaust hood, the propeller, and the spark igniter. Turn on the infrared heaters at their predetermined power. Upon ignition of the oil, stop the stopwatch. Turn off the igniter and move it to its neutral position. Stop data acquisition and turn off the heaters and the propeller. Then remove the thermocouples and extinguish the fire using a non-combustible cover. These data are for the ignition delay time as a function of the incident heat flux from the cone. There is data for fresh heavy crude oil and heavy crude oil that has undergone evaporation. The vertical asymptotes show the critical heat fluxes. This plot is of the heat release rate as a function of time for fresh light crude oil. It has a regular heat release rate profile. Compare this with data for an emulsified light crude oil which had a boil over at the end of the burn. Note the scales are different. Here is the burning efficiency as a function of the incident heat flux for two oil types, fresh light crude and evaporated heavy crude. The data were obtained with the cone setup. Data from the setup also allows a plot of the burning rate for the two oil types. This is an example of the surface temperature as a function of time from two thermocouples in the crude oil flammability apparatus. The spike indicates the moment of ignition.
After watching this video, you should have a good understanding of how to study the flammability and burning efficiency of crude oils under conditions that simulate operational scale crude oil fires on water. Once mastered, the various experimental procedures can be performed in 20 to 60 minutes per experiment if they are performed properly. While attempting this procedure, it's important to remember that although the experimental setups are designed to simulate operational scale conditions, the experiments are still conducted in a controlled laboratory environment, and therefore the results should be interpreted accordingly. Following this procedure, other parameters that influence the problem, such as wind and waves, can be added to the experimental setups to further improve the representativeness of these experiments compared to real in-situ burning operations. Don't forget that working with fire and crude oil can be extremely hazardous, and precautions such as personal protection items, a proper exhaust hood, and the safeguarding of combustible materials should always be taken while performing this procedure.